I welcome all of you in the class. As far as today's class is concerned, in the today's class, we'll be talking about the mechanical properties of the materials from the book of R.C. Hibbeler. As far as the mechanical properties of materials are concerned, today we'll be discussing a very important concept about the testing of the materials. Okay, so as far as the mechanical properties of materials are concerned, we are acquainted with the few properties of the materials. Like we know, as far as the fluids are concerned, we have what we call as the density of the fluid. We talk about the density of the fluid. Okay, for example, I talk about density of water. Okay, at some specific temperature. Okay, at a specified temperature. At a specified temperature. Okay, so this is what we actually call as, this is the property of water. Density of water at a given temperature is the property of water. Similarly, we talk about specific heat. We talk about specific heat. Different materials have different specific heat. Fine. Similarly, we talk about refractive index. Okay, we talk about refractive index. Refractive index, this is also property of the material. Okay, we talk about coefficient of thermal conductivity. Okay, we talk about the coefficient of thermal conductivity. We talk about the coefficient of thermal conductivity, which is also the property of the material. So for different materials, we are having the different properties, or we say that materials have properties. Okay, like material has its density, specific heat, refractive index, the thermal conductivity coefficient. Okay, in the same way, we talk about the coefficient of thermal expansion. Okay, so they are all the properties associated with the materials. Now today we'll be talking about few more properties of the materials which are used in the engineering world. As far as the properties are concerned, before we talk about the properties, let's understand why the understanding of the properties of material is very important for us. The reason for it is, why are we studying the properties of the material? Why are we interested in understanding the properties of the materials? The reason for that is that the materials, whatever material we have, the material is subjected to loads. Okay, the material is subjected to loads. Okay, and what is the property of the load? When a load acts on the material, it tries to deform the material. So the first and foremost effect of the load on the material is the deformation of the material. So when we apply some load on the material is subjected to deformation. Okay, for example, let me suppose we have a bridge. Okay, and this bridge is made of iron bars. Okay, such that these iron bars are supported at two ends. Let me call this as end A and let's call this as end B. Okay, so we are having end A, this is a road. Let me suppose this is a road and this is also a road. So in between the two roads, we are having what we call as the bridge. Okay, and this bridge, let me suppose, is made of a material, say for example, steel. It's made of steel. Fine. So as far as the bridge is concerned, there will be traffic going on the bridge. Okay, and humans will be going across the bridge. So it means, say for example, if we have a truck crossing the bridge, so what will be the effect of the truck crossing over the bridge? The effect of this truck crossing over the bridge will be, first of all, this truck, the weight of this truck, okay, or the weight of this bus will be acting on the bridge. And this bridge is since made of the steel bars. The weight of the truck will tend to cause deformation in these steel bars. So there is a possibility that under the influence of this weight, the bridge breaks. Okay, the steel rod failure occurs, the breakage occurs, and once the breakage occurs in the steel bars, we say the bridge has collapsed. Okay, so there is a catastrophe. We don't want these things to happen. In the same way, if you are making some construction, if you are making a house or you are making a building, so we have to make sure that the material we are using in our constructional purposes as well does not fail at all. Okay, so we should have some parameters in hand by which we can declare or we can define whether the material can fail or not. So that's very important. So the question is, we are studying the properties of the material to have some parameters in hand by which we can decide whether the given material under the given set of conditions will fail or not. That is very important for us. So as far as the so I was talking about the concept of these mechanical properties. So the basic and the fundamental idea in understanding or in knowing the mechanical properties of materials is to have some idea or some formulas in hand, some parameters, I should say, some parameters in hand by which we can decide whether the given material under the given set of conditions will fail or not. That's very important. So the let me talk about, for example, let's suppose we have a bar, we have a metal bar. This metal bar is, say for example, of length L, and say its area of cross section is A. Okay, let's suppose it's hooked, it has a hook at its bottom. Let me clearly draw it so that I mean to say we have a bar, we have a metal bar of length L. Okay, this and its area of cross section is, say for example, A. Fine, it's having hook at the bottom, lower side it has a hook. Let's suppose we have to hang some weight. Okay, we have to hang a weight along this rod. So what we'll be doing, let me suppose this is the weight, we are tying this weight at one end of this hook, and this is the weight. Fine, such that the weight is W. Fine, now the question is, we have to make ourselves sure that as soon as we attach this weight with this metal bar should not crack, it should not fail anywhere. Okay, because if this metal bar breaks at any area of cross section, what will happen? There will be the failure. Okay, so we want to prevent the failure. Okay, by the way, under the influence of this W weight, this force W will be acting downwards. I can say that the normal stress generated by this weight will be equal to W divided by area. This is the normal stress, we have already defined it. This normal stress is created in this metal bar by this weight W. Now if I am given that we have conducted the test of this, we have subjected this metal bar to test, and we have found that when that the maximum stress it can withstand is sigma max, that when the stress generated so in this metal bar becomes equal to sigma max, this metal bar breaks, this metal bar breaks. That is, we are taking this metal bar to a lab, we are taking this metal bar to a lab, and in the lab we are subjecting this metal bar of length L and area of cross section A, we are subjecting it to some load P, and we are increasing the value of this load. So as we subject this metal bar to load P, the stress generated in the lab will be equal to P by A. So increase the value of P. As we increase the value of P, the value of stress generated also increases. So ultimately a particular stress reaches what we call as sigma max, at which the breakage of this metal bar happens. So we call that as sigma max. So we have obtained this sigma max, we have obtained this sigma max by conducting the experiments in the lab. Okay, so I can say that this sigma max has been obtained by conducting tests in lab. Okay, Now when, so this sigma max is in hand, we know now this sigma max, this is the maximum value of the stress that this metal bar can withstand. Okay, now when this metal bar is subjected to load W, the stress created is W by A. I will call this as working load sigma W. Okay, I have to make sure that the value of the stress, working stress sigma W, should always be less than sigma max. Okay, this should always be less than, because if the working stress becomes equal to sigma max, then what will happen? The failure will, the failure will, the failure will happen. Failure occurs. Okay, so it means in order to prevent the failure, I should be knowing how much is the maximum stress that a metal bar can withstand. What gives me the maximum value of the stress the bar can withstand? It is an experiment. It is a test. That's why we're having tension and compression test. It's on account of this tension and compression test that we obtain the maximum value of, we obtain the maximum value of the stress that a machine element can withstand. Okay, so as far as the tests are concerned, that's why we are interested in understanding the properties, the mechanical properties of the materials. Okay, so as far as the tests are concerned, the experiments are concerned, in order to calculate the properties of the machine elements, the first and foremost experiment that we have in hand is what we call as the the tension test. Okay, first we'll be talking about the test what we call as the tensile test or the compression test. Okay, as far as the tension test is concerned, whatever be the material, we have to perform the for example, we have a metal bar. Okay, and we have to see the maximum stress that the metal bar can withstand. For example, we are having any metal bar of any given length. Okay, we're having a metal bar of any area of cross section, of any area of cross section, and of any length. Okay, so before we perform that experiment, what we do, we have to make a specimen. Okay, the first thing we have to do is to make a specimen. Okay, we have to make a specimen of this material. Fine, that is, make a specimen of this material. Okay, so that we can confirm, we can conduct the test. For example, if this length is 10 meter, we don't have to conduct experiment on 10-meter rod. If this area of cross section is 0.5 meter square, we don't have to conduct experiment on the entire rod, on the entire material. Okay, so what we'll be doing, first of all, we'll be making the specimen. We have to make the specimen, and we have to conduct the experiment on the specimen. It is like, let me talk about, like we were fully acquainted with the test, like we talk about a urine test. Okay, we talk about the urine test. So if we assume, as far as a person is concerned, the uh, in one in one go, the a normal man urinates about, say for example 800 milliliter of urine. Okay, okay, if a person goes for urination, he urinates around 800 milliliter of urine. Now, if we have to perform the urine test to calculate how much is the creatinine, how much are the pus cells, how much are the different cells present in the urine, we don't do the urine test on the entire 800 milliliter. We take a sample out of it. For example, we take 2 milliliter out of it. So we do an experiment on how many milliliters? 2 milliliter. This is called specimen. Okay, so in the same way, like a blood test, we don't do the blood testing on the entire blood of the human body. We take a sample out of it. That's called a specimen. In the same way, we don't do an experiment on the entire rod, on the entire material. So we have to make a sample out of it. That's called specimen. As far as the tension or compression test is concerned, in a tension or compression test, okay, the specimen that we use, its length is equal to inch. This is very important. The specimen is used whose length is equal to inch. That is, see, as far as the length is concerned, its total length will be more than 2 inches. Okay, this much of the end is put in the machine, as we'll just see. This part of the end is also inserted in the machine, and we locate 2 points on the specimen, okay, such that the distance between the 2 points is 2 inches. Okay, and this length of 2 inches we call as, this is called the gauge. This is called the gauge length. Okay, And as far as the diameter is concerned, the diameter of the specimen should be equal to how much? 0.5 inch. Okay, so in order to perform the tensile test, we make use of the specimen such that the length of the specimen should be 2 inch. Okay, the gauge length should be fixed to 2 inch, and the diameter of the specimen should be fixed to 0.5 inch. Okay, now go again. Now once we are making the specimen, once we have completed the specimen, what we do, we insert this specimen, we load this specimen in our machine. That's what we call as a universal testing machine. Let me show you the universal testing machine. It is shown here. Here we have a machine. This machine, as given in the book, this is called universal testing machine. This is called universal testing machine, or in simple words, this is called UTM. This is called UTM, or universal testing machine. As far as the universal testing machine is concerned, the universal testing machine, we load a specimen in the universal testing machine such that one end is fixed in the upper jaw. This is the upper jaw of the machine. This is upper jaw. And the lower end of the specimen is fixed in what we call as the lower jaw. Okay, so we are having the upper jaw, we're having the lower jaw, and the specimen is put in between the upper jaw and the lower jaw. As far as the lower jaw is concerned, the lower jaw is fixed. This jaw is fixed. Okay, it does not move. So we say this is fixed. It does not move. Motion is given to the upper jaw. Upper jaw is moving. Okay, by saying that upper jaw is moving, what we have? We have a specimen like this. We keep a specimen. We fix a specimen in the lower jaw. Okay, it is fixed here. Okay, and the upper jaw is, and the upper end of the specimen is fixed with an upper jaw, and upper jaw is given motion upwards. It's given motion upwards. So by giving it an upward motion, what happens? Since the lower end is fixed, the force is being applied on the upper end because the upper jaw is free to move, it goes upwards. So as the upper jaw moves upwards, it creates a tension force. It creates tension or tensile force. It creates tension or tensile force in the rod. It creates tension or tensile force in the rod. So now as far as the rod is concerned, it's like this. We have a rod. It's fixed at one end, and at the another end it is subjected to load or force F. Okay, such that this rod is now under extension. Now what will happen to the rod under extension? What we do, we place two sensors. We place a sensor on the rod. Okay, that sensor is called Extenso Meter. That's called Extenso Meter. What the Extenso Meter gives us? So as we are increasing the load, as the value of this force because of the movement of the upper jaw increases, the rod undergoes extension. Now how much extension it undergoes? How much is the change in length? That is measured with the help of a sensor called extensometer. So the function of the extensometer is to measure the extension in the rod. This is what the extensometer does to us. So now as we keep on increasing the value of the load, the length of the machine element keeps on changing, the strain keeps on building, the strain also increases. Now it's this test, this is called the tensile test, which gives us various properties associated with the machine element, which we'll be seeing in the coming up lecture.